Hi friends, today we are going to learn about how we can deploy our Spring Boot application on Amazon EKS. Basically, Amazon EKS is a Kubernetes service that is managed by Amazon. Basically, it's a cloud-based Kubernetes system that will help you deploy your application on Amazon EC2s, or it could be a serverless Fargate setup, and it will also help you to increase the number of instances or your computing power, like your pods, as the load increases, as the CPU percentage reaches a threshold limit, or you could also point it to the memory limit. So once that limit is reached, it will scale up your number of pods in a horizontal scaling fashion by default, or it can also do vertical scaling if you specify it. Like horizontal scaling is if you basically you are increasing the number of pods in a particular node. Vertical scaling means you are increasing the CPU capacity and also the memory capacity for that particular compute instance or pod. So generally by default it goes with horizontal scaling. So this is the benefit that we have with Kubernetes. It never lets your application um, face memory or CPU threshold, and it will never let your application fail. So that's the basic thing about Kubernetes. Now let's go ahead and see how we can deploy our application on Amazon Kubernetes. So let's go ahead and look at the description here. Amazon EKS is a managed Kubernetes service to run Kubernetes in the AWS cloud and on-premise data centers. In the cloud, Amazon EKS automatically manages the availability and scalability of the Kubernetes control plane nodes, responsible for scheduling containers, managing application availability, storing cluster data, and other key tasks. So with this, you will be able to scale your application in a reliable way, and also you will be taking care of the network configuration and security issues like port configurations, load balancing stuff, and also the security VPC security configurations. So it provides all these advantages. So if we look at the design again, basically it can go on a serverless AWS Fargate or an EC2. For this particular demo, we will use a Amazon EC2 or a node based cluster, and we will deploy our application. So let's go ahead and see how this can be done. So I'm using a previously used application for which I used for my previous videos, which is called a PKC Spring OAuth PKC authentication. The same application I had earlier deployed into a container registry on Amazon. So I'm not going to go into details of how to build the application and how to push it to the container. I'll just go through, I'll just focus on the K8 part of it. Kubernetes is also called K8. So I'll focus on the deployment to Amazon EKS, Elastic Contain K8 service. So let's go ahead and go. So I've checked in all my code into my GitHub repo, which is K8 demo auth. Let's go ahead and see the detailed instructions. So we'll be using Helm configuration for this particular demo. So basically, the prerequisite for any AWS command line setup is for you to configure your profile, user profile. So I have already created a profile called AWS KMS user profile. This particular AWS KMS user I had already used when I demoed the previous demo where I was setting up KMS encryption on some of the secrets. So I'm using the same user. So I'm setting the profile using AWS configure profile AWS KMS user profile. And when prompted, I need to enter my access key, the secret, the region, and we need to export this profile. So once we export the profile, we are set up to use AWS command line interface. After that, we need to create a user, we need to create a ECR repository. This is the same repository I used in the previous demo, so I'm also not going into detail of how to create the ECR repo and all that. Basically this is used to push my Docker container image. Basically that is the place from where K8 will pull the image and deploy it in the cluster. So you don't need to manually pull it from GitHub or the ECR. K8, because it is a container management service, it will automatically deploy it. So you don't need to run the Docker command. In a few seconds we will see how this is all going to come into play. So first step to is that we need to create a cluster in AWS. We have an official documentation. You can refer this document. This is all checked in into the README file, so you can go ahead and check in. But I have given all the detailed steps. Even if you follow the steps I mentioned here and you are well versed with creating the clusters, you can go ahead and create. So basically for that, first we need to create a role that has permissions. So and it needs to have these two policies: Amazon EKS cluster policy and Amazon EKS service policy. So let's go ahead and see what is this user. So basically this is a role. I have already created this role. Let's go ahead and see what is there in this role. EKS cluster role. So basically I have added two different policies or permissions. Amazon EKS cluster policy. This policy provides you the permissions to manage resources, basically how it to access EC2 and all that. And the next one is Amazon EKS service policy. It helps you to create and manage necessary resources for operating the clusters. So I think that is self-explanatory. Once we add these two clusters, we also need to tweak the trust relationship to enable the user that we configured earlier in our AWS profile, which was the KMS user, to be able to assume this particular role. So this is what tells that this particular user can execute these create cluster and all that commands based on the EKS. So that's all we are doing with this particular role. So let's go back. So once that role is created and we are updating the trust policy here, then we create the cluster. So let's go ahead and see briefly how we can create a cluster. See, I have already created a cluster for us here. Let's see what is there in this. I'm using a Kubernetes version 1.24. You can use any version 1.21, 1.23, etc. And it is giving details of different endpoints, the date it is created, and the IAM role. This is the role that we just looked at, right? So it is mentioning the role that is used for creating this particular cluster. And on the resources tab, you can see that there are different resources like pods, replica sets, deployments. Mostly we will use something called pods because our pod will be created in this particular section. Then there is something called cluster. See, if you enable horizontal pod auto scaling, this horizontal pod auto scaling will come into picture. If you go to clusters, you have nodes. I have two nodes. In a few seconds, I will help you understand how we can create these nodes, right? So, and there are endpoints, different endpoints, ingresses, etc. Even this, I will tell you how we can, like there is a Nginx service cluster endpoint. So from what entry type, we for each of the entry type, a endpoint is created. Then we also have config maps. Basically, these are all different config maps that are created. And then there are secrets also. Like if you enable on EKS, you can enable secrets management system where it stores different secrets and secrets as well. So if you create service accounts, which is optional, I'm not creating any service accounts. So if you want to create, you can go ahead and create it. Let's go ahead of roles. There are different roles that are created. Let's go into compute. See, there are two nodes. Basically, they are EC2 nodes or virtual machines, and there is a node group. So this is the concept that we need to get familiar. So on a cluster, you have a node group, and a node group consists of individual nodes or EC2 instances. So here you can see we have a size of 2, which means there are two nodes. Now let's go ahead and try to create a new cluster for us. So I'll just click add cluster create, and I will say demo, and you can choose any version you want. See, if you see, like if you refresh it, once you create a role, in the drop down you can see the role that you had created earlier with the different policies. So you just select those policies, Amazon automatically brings it up in this particular workflow. So once it is done, um, see, this is another feature which EKS provides. You can encrypt your passwords or any such things using base64 encoding. Earlier in our demo, we encoded it using KMS. That is a higher level encryption. This is a basic base64 encryption that KMS EKS provides. So if you want, if you don't want to any information like client IDs which are not super secret kind of thing, then you can use these secrets encryption and just encode them in base64 encoding. That is one part. Generally, it's a best practice to add tags or labels so that you can easily identify them when you are doing some workflows. Right now I'm not adding any tag for this particular thing. There is a default VPC that comes up if your organization has a particular VPC and a subnet in the VPC. You can select them. Right now I'm going with my default options. And if you have a security group as well, you can add security groups in that. I'm just going with IPv4. There could you can also put up a IP address range. If you want to get a particular nodes with only a particular set of IP addresses, so that is one thing. So cluster endpoint. So the cluster endpoint is where it will receive traffic from the load balancer, or if you don't configure a load balancer, it will get traffic directly from the user. So it is from outside the VPC, and worker node traffic will leave your VPC to connect to the endpoint. So for this purpose of the demo, I'm just selecting public, and if you go into advanced, it's saying that it can receive traffic from any particular IP address from outside. If you configure it behind a load balancer, you may want to go with private because you will access it through a virtual private connection. So right now I'm just making it public because I'm not going to configure a load balancer for this demo. And if you want to enable CloudWatch logging for different things like auditing the cluster access or the different API requests that are coming into the cluster, you can select this. Right now I'm not going into this details. Earlier, if you remember, we had configured CloudWatch logs on the EC2, and then we were able to put the logs into CloudWatch. So right now this is being done by the EKS for us. So not the application logs, but the access logs. So access logs into the cluster. So for right now I'm not enabling those. So these are some default options that are by default installed. So I'm not going to tinker with that. So you just select the auto selected items. If you want, you can give a tag, and then you can just click create. So I'm not going to go ahead and create because there is a cost factor on this. So I'll just leave here. So overall, once you click create, a cluster is created. So like this. So once the cluster is created, you would go into the cluster resources, and double check what is there and what has been created. Basically you would have a plain cluster, there won't be any nodes in the initial setup. So let's go back to our instructions. So we have created a cluster, and then the section is create the cluster nodes. So how do we create cluster nodes? There is again a Amazon detailed documentation, but even if you follow whatever steps I have mentioned, you will be able to go ahead and create the cluster nodes as well. So basically what I am saying here is you need to create a role again. I have created something like this and added the below policies, which is Amazon EKS worker node policy and Amazon EC2 container registry read only. So let's go ahead and see what is there in our roles. This is the node that I created for that purpose. And if you see, I have added Amazon EKS worker node policy and an Amazon EC2 container registry read only. Ignore the other one. I just added it for I was doing some testing. Let's go into the trust relationships. Even here I have added the users that I want to assume this particular role. So the KMS user is what I have configured my AWS profile as. So that particular user will assume this role and perform the actions on my behalf when I run the various Helm commands or kubectl commands. So that's the role that I have for creating the node. Now let's go ahead and see how do we create a node. So once we have this policy and the role, we'll create the nodes. Okay, so we go into compute and you can say add node group. Say Krish node group hyphen demo, and like earlier for creating the cluster, this particular node role is automatically comes up in the drop down. So you select that node role with the necessary permissions or policies and add the labels. Taint means which this particular uh, for not selecting this node you use taint. For selecting the node you use labels and tags. So that's the basic concept. So once you go to the next screen, you can select the type of EC2 or virtual machine you want. It is saying you have different options: Amazon, Linux, Nvidia, etc. I'm selecting the basic one, and then the capacity is on demand for this, and it is a T3 medium. You can select whichever one you want, and the disk size is 60 gigabytes. That's more than enough for our simplistic demo. So now comes this auto scaling related stuff. So there are two levels of scaling, right? One for the nodes and one for the pods within the nodes. So this is for the node level. So basically we are saying we need desired sizes, number of nodes that the group should launch initially. So I want the cluster to be launched with 2 nodes, and then minimum size. So the minimum size that the node should have at all the times, that also I'm setting as 2. You can set this as 1, and you can set as 3 or 2, whatever you want. And the maximum size that you want it to reach when there is high load, how much traffic it, how many number of nodes you want it to, that also I'm selecting as 2. Earlier I tried with the desired size as 1, and then I checked it out. So even you can try it out, and this is again maximum unavailable. So when you are updating a deployment, so how many what is the maximum unavailable set of nodes? I'm saying one node should be unavailable. Out of 2, one should be unavailable, the other will be available, or you can specify the percentage as well. So and then I click next. Here again you can select the subnet of your choice, and like the EC2 creation, you need to be able to log into the EC2 if you want generally, and then for that you can select the SSH key pair that I already created and different security groups. If I don't want to restrict anybody, so I'll go ahead and select all. Again, you can give the Kubernetes label that you want this particular node group to be created with, the taints, the tags. Then you click create. Again, I'm not going to go ahead and create click create, because it is I might go beyond my set of limits. So I'll just click cancel. So once you do that, it will take some time to spin up the instances, and then you can look at once it is done, it will say node group is created successfully on the compute tab, and a node group comes up here, and the individual nodes come up here. So these are nothing but your everyday EC2 instances, right? So this is the EC2 instance. You can configure the security here, so you can go ahead. So these two are by default, they are providing access to the VPCs, and I have enabled a 8080 and 80 as well, and there is a overall available traffic available thing that was created, but generally we don't prefer to open like that. In enterprise scenarios, we want to specify the port range or actual ports through which the application is available, because this will be behind a load balancer. Now I want to access it directly without a load balancer, so for that I'm enabling all ports, but that is not a desired practice. This is just for the demo purpose. So this is what we have. So once we have the EC2 instances and the cluster is ready, let's go back to our instructions and see what is next. So next is we want to spin up the Helm configurations. For that, we need something called kubectl. Uh, you can refer this document and you can install it on your choice of a platform. Basically, kubectl is a command line interface like AWS command line interface that manages K8 configurations. So once you install that, you also need to install something called IAM Authenticator. This is used for authenticating the cluster from our local machine. It is similar to the AWS CLI authentication that we have configured our profile with. So next, what we want to do is update our local kube config with the cluster that we have already created. So for that, the command is AWS EKS region, mention the region, and update kube config is the command, and the cluster that we want to update it with is my cluster name. So whichever cluster you created earlier, you use this command to update it in your local ones using the AWS command line interface, and then you can do something called AWS get SVC. Right now nothing is created, there are no services, but if you have services created, you would see something like this. Services is nothing but your clusters and nodes and everything. Once you deploy your application and run your Helm configurations, it will give you what ports it is available on and what is the application that we have deployed, and various ports, like ports are access to the application like node port, cluster IP, etc. So we'll look at these concepts in a few seconds. And then one more helper command, useful command, is to look at the current context. So basically it is saying it is already pointed to this particular cluster. So once you run this, that particular command should output your cluster name. So now let's go ahead and see how do we what is Helm and how do we use it to spin up our application or deploy our container on our cluster that we already created, and how can we specify um, the scaling configuration, etc. So basically you can install it with Brew or whichever tool you are comfortable with, and if you do which Helm, it will give you the source of the Helm, and then what you do is you can clone my application and use the Helm configuration that is already there, or you can delete the configuration which is there in the Helm folder, and then you can spin up your own Helm configuration. So you use the command Helm create and you give the name of your choice for that Helm configuration, and override the default values that are there in the values.yaml file. Basically like the ECR image location, the number of pods that you want, the name of the deployment or application, and the ports, different various ports. So let's go ahead and see what is there in the Helm folder. That so when you run the, let's go back to this. So when you do this, it will create all those basic templates, and we need to override the templates. So once you go into the repo, there is a folder called Helm. Within that, it will create a directory called whichever name you mentioned when you ran the Helm create command, and it will create these basic templates and the values and chart.yml. Basically, let's go into values and see. So basically replica count. So I have put it as 1, which means there will be a one pod or one instance of the container on the node. And based on the traffic, this can scale up to how much ever is supported by the um, node node. And then basically yeah, let's look at that in a few seconds. We are mentioning the image, override the item with your own image repository, uh, and pull policy and the tag. This is again, if you remember, um, when we run our application, we need to create the Docker image and put it with a tag and push it to the Docker repository. I'm not going to go into the details of it because we already did it in our previous demo. The assumption is we are all well versed with running Docker containers. So I'm not creating service account here. It's a nice to have feature, but right now I'm not creating it. And basically we are saying that this is a cluster IP thing because we are not going to access it from behind a load balancer. We will access it directly through the cluster, through the port 8080. That's what we are saying. We can also access it uh, through the node as well, through the individual node by creating a node port. And this is where you can specify some limits. Um, that means this is the amount of resources that your pod will consume. So basically we are saying that your memory should be 128 megabytes. This is not megabytes, it's called megabytes. It is very close to megabytes. 1 megabyte is equal to, and again, 1 point something of megabytes. So you can assume that this is 128 megabytes. And then CPU is, if they say 100M, which means it is 100%. If it is 50M, it means 50%. So it's a percentage of CPU cycles that this particular pod needs to occupy on the node. And auto scaling. So right now I have disabled it. I have not enabled it. Basically it is saying it should have a minimum of 1 and maximum of 100 replicas. Replica is a pod, and basically whenever it consumes 80% of the CPU percentage, then it will spin up a new pod. So right now I have disabled it. For a future demo we can go through that, and even you can configure memory as well as a percentage of memory utilization. So this is with respect to values, that is the horizontal scaling capability. And let's go and see what is there in charts. Here you are giving the name of your application or your name of the deployment of your container. The label, if you want, you would have created while creating the cluster. You can give a label there, but I never created a label for my cluster. I'm just mentioning the same name that I created for my um, application. Uh, Then let's go into templates. Let's go into deployment.yaml. So this is the name that I created in the charts dot YAML. It will pull it up here. The label, if auto scaling is enabled, it will set the number of replicas. If it is not enabled, it just set a number of replicas. Um, and the image, the ECR image name, and the application and the tag, and the pull policy as always, and the container port at 8080, and the name is whatever we have given in the values.yaml. Uh, and that's about it with the deployment, very simplistic. Uh, let's go to the service.yaml, and this we are saying that values.service.port, this is a cluster IP. The value is cluster IP, which means I'll be accessing this particular application through cluster's IP address, and the port is 8080, through the port 8080, and service type is cluster IP. That's all I'm basically I'm creating access to my application here. And I also created a node port.yaml to be able to access it through the node port. Uh, Generally, when you run Helm create, this won't be created. I added this file. So just make sure if you want to access your application through the node's IP address, you need to add it and specify a node port. This is the port with which you will be able to access our application. And this is the port where cluster members like to talk, and this is the port where the container, our Docker container, is actually running our application on. This is self-explanatory. Uh, so these are the basic changes I have done on the Helm configuration on the default templates that are generated. Pretty much straightforward. Now let's go back to our set of instructions in the README file. So once we change those default templates, uh, we will now run our application. I'm not going into details. I'll just give you high level steps because we have already covered it. It's the same application that we used in our previous demo. We'll set the Java home, and we'll export the path, and we will also set the Maven path if you haven't already done, because we'll be using the um, MVN commands in our Docker file. Uh, and then we will execute the um, make package jar command to build our Docker image and push it to the ECR. So let's go ahead and see what is the Docker configuration, and what is the makefile configuration. Again, make is a simple tool that helps us build packages or run some commands and build our application, and then we'll test our application in our local using docker run command. Basically this is to test it whether our Docker thing is running in our local or not. Even I'm not going to run that because I have already done it in my previous demo. Let's go ahead and see the Docker configuration what we have, because we have slight changes. So let's go ahead and look at the Docker file. Basically I'm saying from this image I'm downloading it, which has JDK 11 Alpine JRE, and this will be my work directory, and I would need to copy my generated jar file into the as this particular jar into my root folder and expose 8080, and I'm going to run this command. So when Kubernetes runs my application and pulls my image, it basically runs these commands, and like if you had looked at in my earlier demo, if it is on a standalone EC2, it wouldn't run it by itself. We would need to we had some scripts, if you remember, that AWS code build was running on our behalf, like AWS server start, it was running the sudo java jar. So this was being run by AWS code build when it was building the application, and our AWS code deploy. So, but right now, EKS or the cluster, the K8 Kubernetes will be running this Docker command for us. So that's about with the Docker file, and that is the difference between Kubernetes and other EC2s. Kubernetes is a container orchestration framework. It is designed to run Docker containers. So that's the key here. So and then let's go to the make file. So I'm going to run this package jar, make package jar. So what it does, it does a clean, then it does install, and then mvn install, and then it does container, which is Docker. It is building the Docker image with a particular tag, and this is the Docker ECR registry on EC2 on AWS, and it is doing a push API, and it is pushing this thing, pushing the image to the container registry. So once that is done, that part we have to do. We have to run this make package jar, but the instructions that are there in the Docker file, that will be used by the Amazon EKS platform to run our container. Okay, so let's go back to the set of instructions. So yeah. So once you are sure that your application is good and running locally, you can run make package jar and push the application to ECR registry. Um, and then once the ECR registry is updated with our image, you can run Helm install your whatever name for when you're creating the Helm configuration. You can run that using this command, and it will install the application in the cluster. Basically, it will install it on the nodes, or it will create pods, and it will run the Docker run command, and it will spin up the application for us. If you want to make any changes to Helm configuration, then once, because it is already installed, you want to do a command called upgrade. So it might not accept install because it might say your configuration is already there. So you want to run upgrade, and if you want to just do a dry run, you can use the options dry run with both these commands. So that is a very useful thing, because in production environments, when you want to run Helm, it is very useful tool, because if there are any mistakes, it will tell you upfront. So as you seen earlier, once it is deployed successfully, you could run something called kubectl get svc, like we earlier ran it, and this gives this output. Basically, it tells what are the different interfaces to our application. So it gives something like this. And when you do Helm list, it will list the applications that is installed. And we can also verify this on the EKS cluster by logging into AWS portal. And now then, at this point, you would have deployed your application on AWS, and I have given some of the useful commands. You can also package your um, Helm charts into a jar file and then run it. But generally, whatever we have done is sufficient. So this is optional. While deploying, you would get something called a CNI error. So for that, you need to, when you create the nodes, you will get a CNI error. So for that, you need to refer this particular article, and if you run this command, this will fix it. So that is one particular thing you will face, particular issue that you would face. And these are all some useful things where you want to update it with a particular user's role, because we have if you remember, we have already given permissions to our when we were creating IAM instances, we gave the trust relationship. If you don't mention that, you will have to do something like this for every command. You update it with this particular role, right? When you are updating the kube config, you are saying that with this particular role, it should be enabled. So that is not needed if you already configure it properly. There is something else called OIDC. OIDC, we have not enabled it. Basically, if you want authentication through a OIDC provider, you can do that as well. So for now, we will ignore that. Uh, and some useful commands I have given here. How do you log into your EC2 instance? And how do you install it, upgrade it, you get the nodes. So let's see what this gives us. Yeah, it says the both the nodes are available and ready. And if you do a kubectl get pods, so it says this is the pod that we are running. It's created a single pod because we haven't used much traffic. So once your CPU utilization would reach that 80%, it would scale up the number of pods as well. So right now it is on a single pod on a single node. It did not even deploy to the other node because the minimum number of nodes is one. Number of replicas is one, right? So if we increase it, I think it will increase. And if we put the nodes behind a load balancer, which will set traffic to in a round robin fashion to both the nodes, I think then it will create the pod in the other node as well. So right now this is the pod that is taking the traffic for us. And if you want to check the logs, now that we have deployed our application, you do kubectl logs. And this is one other useful command, like when you go into production enterprise environments, how do you look at the logs for your application? So this is what will provide us the logs. So as you can see, our Tomcat is running on the container, right? Yeah, these are the logs for our Tomcat application. So you can refer this particular thing. Uh, how to set up clusters, cluster IP, access and everything. So you can follow these commands to create a cluster IP port. I have also created a node port. Basically, uh, if you just do this setup, if you just run these commands, kubectl create node port, you need to have a node port.yaml file that I mentioned earlier, that you was shown in the demo earlier, few seconds back. So just use that and create a node port if using these commands. Basically, you are creating a node access to the individual node. Let's see what. So I'm not going to run that again because we have already created it. I'll just try to get the node port details. So it is saying it is accessible at this particular IP address at this particular node port. So once you have the node, we need to open access to that particular node. So if you remember, when we looked at the security tab of our nodes, see this particular node 31479 has been given access. So you need to provide access by editing the security configuration. Okay. Let's go back to our instructions. And now let's try to access our application, right? Uh, so I'll try to access it through the load balancer. As you can see, it is giving me the login page for my Spring OAuth page. Now let's click the by the way, you will have to point it to your own IP addresses, like when you run kubectl get svc. This is the command that you would use. Yeah. So this is the node's IP address. So you're using that, and then you're using it with this particular port. So the one they show here is not the node's real IP address. It's a cluster's fake IP address that they are showing. So it will take some time for you to figure that out, but that is the thing here. You need to use the node's IP address and with the node port that you created. And let's go ahead and see if your application is running. So I will do authentication using my username and password, and this will give me a access code, which I will mention it here. And I have already updated the IP address to my node port IP address and node's IP address and the node port here. So hopefully we'll get a response. Maybe we'll try with this load balancer. I think it's getting a timeout. Go back here. Copy this. Yeah, so this one is working right now. So sometimes I have seen that there are some network issues, probably because we are accessing the nodes directly. I think the right way to, sometimes it works, sometimes there is some latency. So there are some latency issues, but I think if you put it properly behind a load balancer, then that setup would be the best setup for accessing, and probably even because there are some threshold on the capacity, because this is a basic account. So overall you can see that this is working fine. So yeah, so what basically everything that you need to do, set up a simple Spring Boot application on a AWS EKS cluster is all mentioned here. If you follow them to the point, you will be able to set up a EKS cluster on Amazon EKS. So that's all I have for you today, friends. Please support me, uh, and we'll meet again with another good session. See you.